Hey, hello guys. Welcome to the channel Views of Principle. Today, we are going to look into an interesting topic that is multiphysics. As we all know that multiphysics, yeah, we live in a multiphysics world. It's a real life process, are inherently multiphysics. From atoms to galaxies, from amino acids to living organisms, naturally built systems involve various types of physical phenomena operating at different spatial and temporal scales. Yeah, let's move on. Yes. What is multiphysics? It is a coupled physical phenomena in a computer simulation. It is also a study of multiple interacting physical properties. As this is an interdisciplinary field, multiphysics simulation can span many science and engineering problems. So this simulation methods can include numerical analysis, partial differential equations, heat transfer, and tensor analysis more and more. For example, a natural fire is from lightning is a typical electrostatic. So it is a thermal and chemical phenomenon. Fire starting with a handrail involves both mechanical and thermal process. Surprisingly, while multiphysics is a part of nature and history of life, the study of multiphysics is not new either. Yeah, multiphysics software. It is a connection between the simulations to real world examples. Fluid forces, thermal effects, structural integrity, and electromagnetic radiation can all affect performance. If you isolate these forces and examine them separately, you may not get an accurate prediction of product behavior. So there are various best softwares, ANSYS, ComSoft, OpenFOAM, MATLAB, etc. More and more are softwares were available in the market. So these interactions can impact the product safety, longevity, and we can also look at the thermal effect, structural integrity, and electromagnetic radiation can all affect the performance. So that we have to simulate and we have to analyze the whole problem. In fact, multiphysics has been developed beyond a research concept. For example, in industrial design and product testing, engineers used to solve one physical phenomenon at a time, such as structural integrity, then import the results into another system to solve for the aerodynamic behavior. Multiphysics simulation tools now allow to simulate and analyze both these behaviors and many others at the same time. So yeah, multiphysics simulation process. So this is the implementation of a multiphysics simulation follows a typical series of steps. So first we need to identify the aspects of the system to be simulated. And then we need to include the physical process, starting conditions and boundary condition. And second, we have to create a discrete mathematical model of the system. And then we have to solve it numerically. We have to solve the model numerically. And finally, we have to process the resulting data. Multiphysics is defined as a coupled process or systems involving more than one simultaneously occurring physical fields and the studies of our knowledge about these processes and systems. For example, objects moving due to Newton's second law will be viewed as an example of multiphysics. ANSYS. Yes, ANSYS is one of the best multiphysics software. We can help to examine all the effects. So yeah, these are the four major applications we can look at the ANSYS multiphysics software. First thing is fluid structure interaction, and then thermal management, and microelectric machinery systems, and finally turbo machinery. So all these, however, a model of a star cluster that resolves Newtonian gravitational interaction or molecular dynamics. But according to Newton's second law, we can view the example of multiphysics as long as velocity will be calculated at every point of the domain. From mathematical perspectives, system consisting of partial differential equations of different types, that is elliptic, parabolic, elliptic hyperbolic, or parabolic hyperbolic, may be classified as multiphysics because each of the classical PDE archetypes possibly represents a different physical phenomenon. So yes, the applications, fluid structure interactions. With ANSYS multiphysics software, engineers can simulate the interaction of fluid forces with structures to receive a deeper understanding of they can analyze a stronger things of the product behaviors. And then thermal management. So it's the most importantly that we have to maximize the performance output in thermal management. Fluid flows can be analyzed to see how flows can cool and heat the machine parts or the equipment in, for example, in electric vehicles. Next, micro electromechanical system. So at the heart of IoT devices, micro electromechanical systems are constantly being improved. This software answers have the ability to test for numerous complex factors in day-to-day complex Internet of Things. And yeah, turbo machinery. So ANSYS provides the complete end-to-end solution for turbo machinery, whether it is jet engines, turbochargers, wind turbines. So it provides an end-to-end solution. So we can redefine the product limitations by using only ANSYS. And we can also help to identify areas where you can maximize your product performance and efficiency through this ANSYS multiphysics software. Yeah, you can see all these three are the heart of multiphysics. So these are the few hearts. The first thing you can see is a bubble blow. So this phenomenon is like a fluidized bed. You can see that there is captured. So this is using CFT coupled simulations. It's one of the best heart of multiphysics. And then second, you can see the shock. So it's an 100-bar air water shock tube. It is used to generate a shock wave in a tube. It is traveling around 1,500 meters per second. So it's also one of the best heart of multiphysics. And then at the last chapter is ChartP. ChartP test. We all know that to test toughness testing. So this test is well known for testing materials. So it is a destructive method of testing. So it's also one of the best art of the multiphysics. Yeah. So future. What will be the future of multiphysics? In multiphysics, the opportunities and the field is going higher, higher, and higher every year. This engineering simulation plays a role in not only designing the vehicles or rockets or any kind of a batteries. It also helps to design the buildings we live and work, cars, smartphones, and even medical devices, our computers, our food, and much more. So ANSYS first introduced simulation software more than 4 decades ago. It has dramatically grown in its adoption by engineering terms in various industries in various disciplines. The Institute of Plasma Research, what they've done is they leveraged the power of multiphysics to simulate, and they investigated how nuclear fission can be accomplished via magnetically confined plasmas. The derived components for fusion machines are specifically designed for very large loading conditions. And it is complex in their design, but it addresses the complexity, and their research conducts a large number of iterative simulations that bring together structural, thermal, and electromagnetic analysis. Multiphysics is not a small, it is a vast topic. It goes on. The MAC here includes both the basic language for talking about multiphysics, such as tensor analysis and differential equations, and the tool for acquiring solutions. So multiphysics is very interesting actually. Multiphysics is an art of mathematics, physics, and applications. Thank you. So we will see you next with a interesting topic. So don't forget to subscribe. Views of Princeton, more to come. Bye bye.